Hello, students! Have you ever looked up at the sky and wondered, why is the sky blue? Or maybe you've watched a beautiful sunset and thought, why is it so red? Well, the answer to both these questions is a really fascinating topic in physics called the scattering of light. Today, we're going to explore this together.
So here's our plan for today. First, we'll start with a simple observation you might have made at home. Then, we will understand the science behind it. After that, we'll see how this science creates all the beautiful colors in our world. And finally, and very importantly, we'll discuss some key tips for your exams. It's going to be a simple, step-by-step journey.
Okay, let's dive right in.
I want you to start by thinking about something you have all probably seen. Imagine a dark room, and a single beam of sunlight comes in through a small opening. Suddenly, you can see the path of that light beam, can't you? But why does this happen? What is going on that makes this invisible path of light suddenly so clear to us?
Well, this beautiful effect has a name, and it is the main topic of our lesson today, the scattering of light. You see, the tiny dust or smoke particles in the air act like small obstacles. When the sunlight hits these particles, they just throw the light in all different directions. Some of this redirected or scattered light enters our eyes, and that's how we are able to see the beam.
Now, this scattering of light isn't just a random thing. It has a proper scientific name and some very interesting rules. So let's take a closer look. The effect that you observe, this visible path of light, is what we call the Tyndall effect. It's a perfect example of scattering in action. So whenever light passes through a medium that has very fine particles suspended in it, and the path of light becomes visible, we call it the Tyndall effect.
And you can actually see this effect in many places if you just look for it. For example, in a dense forest, the tiny water droplets in the mist scatter the sunlight, creating beautiful rays. Or in a cinema hall, it's the tiny dust particles in the air that make the projector's beam visible to everyone. These are all real-world examples of the Tyndall effect.
Okay, now this is where things get really interesting. Scattering doesn't just make a light beam visible, it also plays with its color. The secret is that not all colors of light are scattered equally.
So here is the main rule to remember. Sunlight is made of a mix of all the rainbow colors, VIBGYOR, right? Now, the very small molecules in our atmosphere find it much easier to scatter the colors with shorter wavelengths, like blue and violet. On the other hand, colors with longer wavelengths, like red, they tend to just pass straight through. This one simple idea explains so much.
So let's move on and see how this one rule, that blue light scatters more and red light scatters less, is responsible for some of the most beautiful sights in nature.
This is a classic question, a favorite in exams, and the answer is pure physics. It's not because of the ocean's reflection or anything like that. The actual reason is scattering.
So here's exactly what happens. As sunlight enters our atmosphere, the tiny gas molecules act like billions of tiny mirrors, but only for blue light. They catch this blue light and scatter it everywhere, in all directions. That is why, when you look up at the sky on a clear day, you see this beautiful blue color coming from all over.
So it's really that simple. The blue color of the sky is a direct result of sunlight being scattered by the tiny particles in our atmosphere.
Now, let's look at another very common reasoning question. It uses the exact same principle, but in a slightly different way. If the blue light is scattered the most, why do we see a red sun?
The answer to this mystery has to do with the time of day. You see, at noon, the sun is directly overhead. Its light travels a shorter path through the atmosphere. But during sunrise or sunset, the sun is near the horizon, so its light has to travel through a much thicker layer of the atmosphere to reach our eyes.
Now, because of this longer journey during sunrise and sunset, almost all of the blue light gets scattered away. It gets lost before it can even reach our eyes. So the only colors that manage to travel all that distance are the ones with longer wavelengths, which are red and orange. And that is what we see.
So you see, it's not a different science. The very same principle of scattering gives us both a blue sky at noon and a red sun in the evening. They are just two sides of the same beautiful coin. Okay, now that we know that red light travels the farthest without getting scattered, can you think of how we use this idea in our daily lives? It's all about keeping us safe. The reason is all about safety and visibility.
Since red light has the longest wavelength, it is scattered the least. This means it can travel through fog, rain, or smoke much better than any other color. So, even in bad weather, a red signal can be seen from far away, which gives people enough time to stop or react. It's physics at work, saving lives.
All right, we have understood the science. Now let's talk about something that is very important for all of you, your exams. Knowing the concept is one thing, but writing the answer correctly is how you will get full marks. Please pay very close attention here. Questions like why is the sky blue or why is the sun red at sunset are extremely popular in board exams. They are often asked as reasoning-based or HOTS questions, and they are designed to check if you have really understood the concept deeply. Here is the golden key for answering these questions. No matter what they ask, blue sky, red sun, red danger signals, your answer must include the phrase, due to the scattering of light by the atmosphere. This one line immediately shows the examiner that you know the fundamental principle. After that, you can add the details about shorter and longer wavelengths to get full marks. So I will leave you today with a final thought. We've talked about blue and red, but our sky shows so many other lovely colors, like orange, purple, and pink. I want you to look at the sky and think about how this same principle of scattering might be creating those beautiful shades as well. Keep observing and keep questioning.